actually, that's my bio that I write to have fun. Despite my checkered past, I am a contributing member of society. It's good. It's good. But today it's death by pickle today. Strap in because we're going to move fast. Eat, leave, do what you got to do. I've never had a talk during lunch outside of the Marine Corps where you know, most people they got MREs and we're breezing. But who am I? I am a born-again former United States Marine. So if it feels like somebody dropped a revival tent into boot camp graduation, you're probably in the right place, right? I did found a thing called SnowFROC, which is a lot like LASCON with altitude. So it's in Denver. If you're in Denver, if you like, how many people is your first LASCON? Okay, what do you think? Okay?
Well, I'm a developer, so it's
you poor bastard.
Kind of one-sided.
Yeah. Okay, well, if you have fun, the thing that LASCON and SnowFROC have in common, they're both community events. They can be very intimate, and you can learn as much as you want to learn. So it's great. Today, though, I am a technical marketing manager. I don't know what that is either, but my background qualifies me to talk to you about a lot of fun things, and that's why I say that. So I work for a company called ReversingLabs. I'm not here to sell you today, but what does ReversingLabs do? If I say 24 petabyte data lake of samples, that's a lot of data. That's excluding the metadata and the analyses data around that, right? So we take that data, we've been collecting that data off and on since 2009, about a little over 1 million new samples analyzed today. The magic is recursive binary analysis. How many people just had their eyes crossed? Yeah, okay, recursive binary analysis. Basically, if you look at compiled code, it's what? It's ones and zeros. That's what it is. This pattern of ones and zeros that is the phone home module for the North Korean 0 day from last week, man, that series of ones and zeros looks a lot like this series of ones and zeros. I've seen this before. I've seen something like this before. I can draw conclusions. That's ReversingLabs, right? We go ahead and dive in. We do pattern matching. We would never reverse engineer because somebody's lawyers would have a problem with that. But we do that pattern matching and that binary analysis, and we're good at it. We're right outside if you want to swing by and meet us. We got Katie talking at 3. If you've never heard Katie, you should do it. She's a lot of fun. And so what she's going to be talking about, how many people are developers in here? Okay, 1. Okay, how about cyber? How about your Appsec humans? Okay, all right. Audit, GRC, anybody? Management of any of the above? Yeah? What, GRC management or? Okay, so management general. Okay. All right, well, so Katie's going to talk about dependencies for those of y'all that care about development, those of y'all that care about cyber and especially Appsec. Dependencies matter. There's ways to do them right, there's ways to do them wrong, but she'll be talking about that. It'll be great. So let's start out. What's worse than vulnerabilities? Exploits are worse. But what's worse than that? Hey, when I pull in a dependency and it's backdoored, yeah, what happens, right? I do my release, and in my package is a pleasant surprise, dressed up like a Trojan soldier, just for anybody. But what's worse than that? Anybody? Got to say AI, right? Yeah. So a Trojan with AI, and it's worse than that. Okay, we're on a roll. What's worse than that? Nobody's gotten this right yet.
I was going to say a ton.
Okay. Or as my old boss used to say, John Wick 4. John Wick 4 is worse than anything.
Ejected compilers.
Oh, yeah. I don't even know what that means. So we'll revisit that later. Okay. So it's worse than John Wick 4?
Absolutely.
Okay. All right. there's an old expression, why do people rob banks? Because that's where the money is. Why do we see supply chain attacks? Because they frickin' work, right? So I talked to a large military audience a couple of weeks ago. You have whatever, you've got a road that you think you're controlling with whatever controls you have, in this case something like a gate, right? And you've put a lot of money into making that gate state of the art and everything else, and you know nobody is going down that road without going through your gate. What's happening with your key vendors and your upstream suppliers? They ain't going through the gate. You invite them through the gate. You checked them through the gate. So that's why supply chain attacks are working. That's why it's going on. Did I lose anybody? Is everybody still with me? If you're not, it's okay to say no. All right, here we go. So what can you do today for free? So we're going to run through some things today. One of the things that ReversingLabs decided to do is create a community site. If you don't have a taco in your hands, go ahead and go to secure.software, right? And just bookmark it, all right? Not secure.software.com, but secure.software. And you'll see why in a second. I'll walk you through a couple of things that are really interesting. Is there anybody who didn't know that NPM had a couple of issues? Yes. Okay, all right. So nobody's lost there. Go to secure.software. Up in the upper right-hand corner, and this is not going to render on your phone, guys, and the Wi-Fi is down, so I'm not doing it live. But go to the upper right-hand corner, hit Communities, pick NPM, and then go ahead and let's filter on malware, and let's filter on the top 10. And what you will see if you do that is that 5 of the top 10 packages on NPM have been backdoored in the last couple of months. When we say top 10, what does that mean? It means the ones that are getting downloaded the most, the ones that are being included the most. Literally the most pervasive software in the NPM universe. 5 of the top 10 have been backdoored. So what do you think? Should we do something to check that? Yeah, that's not a bad idea. Let's talk about how we can do that one-on-one. So this is an example of typo squatting, and gang, just so you all know, I've showed this to several customers, showed it to several professors. It becomes a class. So if you like this, what you'll see is you in your shop can run people through this and go, yeah, hey, we do a lot of Python, let's go to PyPI, let's look for this thing, cryptography. Hey, look at that. The number one hit is a library called what? Cryptography. It's the top 100 library. It's a key project. It's not perfect, but it's not evil. If you scroll down a little bit, you guys see this? Do you see the setup? Right? What is typo squatting? I don't know. Hoping somebody will type in one additional Y character into my malware-infested package that you thought was going to handle your cryptography. Not that that's sensitive, right? Same thing, right? X cryptography. What is going on here? So is there anybody that has a question about what we just did, how to do that? Because we're going to get out of the free part here pretty quick. Just kidding. Okay. So everything I showed you, one of our customers is, let's just call it a large Department of Defense agency. And you may be aware of some financial constraints that have emerged recently within many U.S. federal agencies and organizations. So what we just went through, how many people think manually searching for library scales? Oh, one. You're the manager. You're the manager. You got to know better than that. All right. Thank you. All right. So it doesn't, but you know what? If you're constrained, yeah, let's do it. Let's take a look. So we had one agency where one individual, is there anybody that doesn't know what an SBOM is? SBOM. Who's never heard of it? Raise your hand. Okay. Who wants, so the rest of y'all have heard of it. Who wants to explain what an SBOM is?
Ingredients of your software.
Perfect. You mind if here, let's try that again.
So it is ingredients of your software, like you're cooking your software and you have to make a list of what you're using in your cooking software.
Yep. Yes. Yes. All of it. Yeah. Well, it's easier for some people to think about it. Yeah. So he was given an SBOM by a vendor. He was assured. Now, what are the data elements in an SBOM? Components, and in an SBOM, you're supposed to have CVEs, right? Vulnerabilities. That's the standard. He was assured by his vendor, hey, there are no vulnerabilities. Yeah, because that's the way the world works, right? It's perfect software is released all the time, including all your open source components. Yeah. Perfect turnkey software. So that's it. So we stepped through a couple of ways to leverage the free stuff, and this guy did that. He's like, yeah, I don't believe you. Hey, I see this NPM library. I'm just going to go up on secure.software and look at it. Hey, you guys have got it tagged as this version. When I look at this version on secure.software, not only are there vulnerabilities, there's some other ugliness too. It doesn't scale. It doesn't scale, but it leverages a 24 petabyte data lake of research, and it's free. So, and by the way, if you think ReversingLabs is paying for me to be here based on all of our free stuff and how we're, that ain't the way it works. The commercial software scales, right? All right, so let's talk about pickles. Anybody got pickles for lunch? All right. How many people don't know what a pickle file is? 1, 2, 3. Okay, great. 4. Okay, we're going to go through that. And guys, the origin of this talk, I was standing in a cluster of security professionals, and they were all yucking it up and laughing at each other about pickle this and pickle that and that pickle and the other pickle and ha ha ha. And I'm the ignorant guy, right? I'm the frickin' marketing guy. Hey guys, what's a pickle? And they all looked at their shoes. So you're not going to have to look at your shoes after we're done. What's a pickle? Look, we'll start with taking a step back. What's machine learning? What's a machine learning model? I know stuff, right? Is there anybody that doesn't know what a machine learning model is? What an LLM? Okay, good. That's what it is. What's the easiest way to explain that? Is there anybody who has never seen The Matrix? Going once? What's that?
What's the easiest one?
No, have you?
An easy way would be just describing a graph with points on it, then drawing a shape on it if you're describing an LLM that's a tokenizer.
Now you're killing me.
So
Yeah. You're killing me, man. All right, so say that again and recognize you're being recorded.
Okay, so an easy way to describe an LLM that's a tokenizer is to say you have a graph, like an X and Y coordinate graph, the points on it. Those points represent data. Your tokens are a function, they're a shape on that graph. It could be a dog, it could be a cat, it could be a jellyfish. But that shape encapsulates some dots, and those dots are returned to you. And so you keep, every token draws a different shape on this data, and you get it back over and over until you get the end of whatever it is, the end of the tokens.
Did you guys get that? So thank you. Which of those tokens is supposed to be dynamic code?
Which of the tokens is supposed to be dynamic code?
Yep.
So none of the tokens are dynamic code.
None of the tokens are dynamic code, you say? Okay. Well, let's go back through this, right? So we're going to take a little side trip for a second, and then if you think none of the, yeah, we'll go there, right? So a pickle file is I know kung fu, right?
Oh, okay.
And then it's basically serialized data that makes something portable, right? So if I've got I'm building an AI. That AI needs to understand written Hungarian, right? If somebody's done that once and made that public, I can add that into my LLM. I can make my AI aware, right? My AI knows Kung Fu or knows Hungarian or whatever it is, right? How reliable is AI right now? So I wanted to do some diagrams for this talk. And so I went up on Gemini and Grok and said, hey, do this, right? So any questions about this? Have you got a picture in your mind about what this ought to look like? So there it is. That's what Grok heard, right? Okay, what Gemini heard? Hey, it's the same thing, right? Same answer, right? Looks different. There was one movie, there was one actor, there was one line. Not a lot of variables there, but this is what we came back with when we asked it. Okay, well, what if we ask AI to imagine something that's never happened? Is there anybody who's never seen Pinky and the Brain? Say it with me. What are we doing tonight?
Taking over the world.
Taking over the world. There you go. So Pinky and the Brain meets the Matrix. Do me a favor. I'm going to pause for a second. Just read this. Read this and think about the image that you would expect to come out. Going once. Going twice. This is what I got. Yeah, wow. Right? So we take for granted that if I'm going to describe a human, it doesn't have 3 arms. Even if you're mixing it up with a mouse, under no circumstances does it have 5 appendages plus a tail. Right? This is AI working normally. We also went ahead and made up some words apparently. And I don't understand that. But that's the output. You guys saw the prompt. It's exactly what I put in. This is exactly what came out. So let's mix it up. Same thing again. Is word for word, same thing. Let's add a flaming sword. Think about what you expect to see. Give it a second. And here we go. Okay, now, be honest. How many of you expected 3 arms? Yeah, okay. So it didn't do the 3 arms, which is cool. And it did something really fun with the ears, which is nice. But it's got a flaming hand. Okay. So guys, what's the point of this? The point of this is AI. This is world-class AI. This is Google Gemini working normally. All right? Okay. Well, that's fun, but let's get to the really fun stuff. So once upon a time, somebody asked themselves, hey, if it's all just kind of these points on a curve and none of them are supposed to be dynamic, what happens if I try and put in some dynamic data that could execute? What would happen? Well, you'd have something like PyTorch, which this is Wikipedia, and then in 2022 you'd say, oops, that's not lines on a curve. Say, this thing is doing something. That's okay, that was 2022, not a problem. Again. That's okay. Hey, we're learning. You know, you gotta break some eggs to make an omelet, right? Hey, you guys get the point? Have I beaten this dead horse to death? This ain't going away. So what's that deadly pickle file? That's the elephant in the room. Let's talk about the deadly pickle file. So this is the deadly pickle file. This one, it's not very big, but it does some things that are really interesting. Remember how you said it's not supposed to have code, right? It's supposed to have data. That's the assumption, right? And guys like me and Matt have been around long enough to remember the days where funny things happened with self-replicating code that was embedded in data that was treated like code. Like, you don't do that. We have data goes over here, code someplace else, right? In this case, hey, I've got a file that can create new processes. That doesn't sound right. Hey, what else does it do? Oh, it knows networking. Super cool. Oh, and once it gets done downloading that backdoor, it can run it. Seems suboptimal, right? So you like that? Yeah. So again, it's almost anticlimactic, right? Hey, we found some things in your data file that are a little bit malicious. Everybody with me? How are we doing on pace? Is this okay? Okay, good. All right, and you guys know they're shutting down lunch at 1, and you're not going to hurt my feelings if you get out and get lunch. All right, here we go. So what's Hugging Face? Anybody know? Yes, sir.
It's a repository of large language models that people have been developing for specific use cases, kind of like the pickles you've been describing.
There you go. That's exactly right. It's a repository of large language models, kind of like the pickles I've been describing. A little heavier on the data side, we hope, right? Okay, so are there pickles on the web? Yes, clearly there are pickles on the web. If I want something like a QR code reading capability, I can go to Hugging Face, and it's hard to see, but in addition to all this stuff that popped on top, there's 62 models, right? So I can pull that down. If somebody else did it, and it's only supposed to be data. It's only supposed to be data.
Well, hold on. You're kind of confusing what data and code application use is. See, models in this context, see the spaces at the bottom where it's talking about how you're taking a model and you're turning it into a product, right?
Yes.
And you have your data sets, which are like things that you're using to process and train your model.
Yes.
So you might have QR code data sets that you use to train a model that you'll apply to a space and present to the public for use. Somebody can download that data model, right? But it's catered towards what that space is going to be. So there's an angle to it, I guess. There's like...
And will we expect code in there? Are we at that point yet? Where are we it's still just data, right? So what you just said is, hey, look, there are a lot of actually different kind of, I'm going to say permutations, right? Different applications of what's up there, depending on what you need. One of them is to train something. One of them is just, I know Kung Fu, pull it in, right? So, but none of them are supposed to have have code. Yeah. Okay.
Do anything other than just be read from.
Yeah. So if I slurp it in, did you guys catch this? So if I slurp it in, now my AI knows Kung Fu or QR code reading or OCR or whatever I wanted it to do. This came out shortly before I was finishing my deck. I love it. Is there anybody from Tesla here? Anyone? No? Okay. All right. What would we do to test these? So how many people think that malware testing is highly effective?
The testing, or, I mean, I assume that testing would be useful.
Okay, so testing is useful. I think highly effective is probably not right. One of the things about
You have to know what to test for before you started in order for it to be highly effective.
So probably I have to have seen it before, for the most part, to identify malware. One of the dirty little secrets of the malware industry, those of you that have done cyber, if you assess something that's too big for whatever it is you're trying to test, what does it tell you? It'll tell you no malware found. Is that the same as no malware? What's the difference?
It's too big to 100% accurately scan through.
So too big to scan through is one case, right? Or, hey, I've got malware that doesn't speak ELF, for example. Or I've got a malware analysis tool that is useless in Linux, right? It doesn't know. And so what does all malware assessment, what does all that tooling do? It'll hash, it'll compare the hash to a reputation database. If it's got a bad reputation, malware found. If it's got no reputation and it can't do a full analysis, what's the report? No malware found. But you got to do it. You're right. You got to do it. You got to check for it. You got to check for tampering. So if you're familiar with supply chain attacks, you'll know that especially in the case of nation states, what's the first red flag? Something subtle, right? So in the case of SolarWinds, which is probably the most famous supply chain attack in the history of the world, anybody know what the first red flag was? Anybody besides Dave or Matt? There was a new class introduced. Did you guys know that? There's a new class introduced into the release, and by whom? By the guys that are on SolarWinds payroll? No, right? So that feels a lot like tampering. In the case of 3CX, the release that was compromised, there are 17 major releases before it. There are hundreds of dot releases before it. This is the first release that had a partially signed package with malware on the back end. Well, did they do it on purpose? I don't know, but I kind of got to ask, because it kind of feels like it might be tampering, right? So you want to test for that. Show of hands if you're 100% confident in your ability to check for tampering right now. Looking at you, Matt. On software, on your release.
There's no way. How are you going to have that much knowledge in your head?
You know what? You need to stop by the table because I will help you answer that question. So, but the point is that capability it's the way to understand a subtle attack, right? And it's got to be something based on behaviors over time. I have a customer that they've got a very distributed development team. One of the things that they look for that's a red flag for them is if at any point their app starts to test to see if it's running in a virtualized environment. Who cares if you're running in a sandbox? Bad guys, right? So if I've got my paid developers around the world, some of whom I'm never going to meet in person, and I suddenly have a commit that has a couple of subroutines that wants to know if it's running in a VMware box or in another kind of a virtualized environment. Is it bad? I don't know. Is it a question I have to ask her? Yeah. You got to have an answer, right? Are we doing this on purpose? So tampering can look like that too. Vulnerabilities, everybody cares about vulnerabilities. They matter. And you want to test for them because you don't want to release vulnerable code if you don't have to, right? So when we do that, we leverage this behavioral diff I told you about in my customer that looks for the newly introduced behavior of sandbox testing. You want to be able to do it fast. We went through a manual process. It's not scalable. It's great for one-offs, but automation matters. I spent 2 days with Matt earlier this week learning how to make automation matter better. I wish I'd been a better student. You're a great instructor. And then we want to be able to share the report, right? If I want something fixed, either I got to fix it myself or I've got to be able to describe in detail what needs fixed with whatever the source is of that thing. So report sharing is a thing that we're going to want to leverage. All right, and don't forget the paperwork. Okay, some of you are still awake. Those of you that aren't awake, hey, go get lunch. It's not going to hurt my feelings. All right. S-bombs, C-bombs, AI bombs. Is there anybody who doesn't know what those are? It's okay. Okay. So S-bomb is that software bill of materials. C-bomb is an emerging standard. It's a cryptographic bomb. It's in the same document. It's in the same output. But because quantum computing is going to represent a bigger risk, people are inventorying for crypto elements now. Yeah. You need to stop by the table. I love you. You got to stop by the table. AI bomb is, hey, how did Copilot treat everybody? Surprise? Yeah. AI bomb is, I'm shipping stuff that has AI elements. Okay, cool. All right, so that's what paperwork looks like.
No.
Yeah, no. Yeah. Nope. And why is that? We touched on this a little bit earlier. Okay, let's scope the problem. So this is Mistral. It's an LLM. It's 36 gig. Go ahead and hold up your hand if you've got tools in place right now that'll let you look at a 36 gig file outside of hashing and reputation and go, yeah, that's what this thing's built to do. It's got executable code where it should only be data. No. So and when we talked about Hugging Face, some of the packages in the Hugging Face are what? They're freaking enormous. So you see, is there blame to go around? Sure. Is it a hard problem to solve? It's a hard problem to solve. But surely it's easier at 11 gig. Yeah, not really. Exactly. Does anybody know the threshold? About 750 or 650. I think VirusTotal is they got a 650 meg threshold, and some of the and some of the most popular sandbox technologies out there, 650, 750, and you're done. So you can bring your 11 gig bad seek with you, put it in your sandbox, and then go get lunch today and tomorrow and the next day, and you know, it ain't happening, right? So that's a part of the problem. Is there anybody who doesn't know who Jim Manico is? You can say you don't. Do you know who he is?
Oh, yeah.
Okay, good. All right. You don't know who Jim Manico is. Okay. So I told you I founded SnowFROC, right? I founded a couple of OWASP chapters. Jim Manico has been teaching application security since before I did that in 2006. He's one of the leaders at teaching application security, right? So, and Jim Manico said, you know what? AI writes horribly insecure coding unless you teach it. And I'll share these links with you later if you'd like, because the next link is, yeah.
Is he just in Red Ballroom?
He's here. He's here. Yeah, if you had a chance to listen to Jim and you're listening to me, you made a mistake. I'll just tell you. Right? So, but one thing he's done, so there's a free React edition, which is great, but free's not free. Why?
Because Jim explained that he needs to make money.
Yes, yes.
Because I asked for the rest of it.
Yeah, that's it. Well, and so again, I don't care if it's Jim or anybody else. I love Jim. He's a great guy. He's an amazing asset for this community and for the rest of the world. But man, if I'm getting his stuff, I'm still doing my checks. You see that? And I'm still going to leverage these other things because, like you said, there's not supposed to be code there. Right? So, okay, so let's do that. And that's before you get into that whole risk surface of, yeah, you know, I've released some AI that is actually prone to doing evil. Right? We're not talking about that today. We're talking about something like the nullify would actually open a reverse shell. That's what its payload was. So if you're relying on nullify to teach your LLM anything, what's your LLM going to learn? Whatever the guys on the other side of that shell want it to learn. You guys with me? So anyway, I need to take care of that, and I need to do the paperwork. Okay, no laughs there. You guys see? you guys see why this is hard? Did I lose anybody? You guys with me? Okay, all right. So I think the final quiz, what's a pickle file? You can't answer. Who wants to say what a pickle file is? Don't look at your shoes. You know how this started. Mail. Who wants to tell Mayo what a pickle file is? Can I put you on the mic again?
Me?
Yeah, you.
I would say the one that doesn't let you sleep at the night.
Okay.
Python's pickle file is it's different than that one. It's a file that's Python bytecode and that's usually used to store JSONs.
Serialized data. Serialized data. That's what a pickle file is. The easiest way to explain it is just, hey, Neil gets an upload, he knows Kung Fu. I get a pickle file, I know OCR. That's one way to use it, right? A little surprising that you could put backdoors in that, but you can. All right, so that's what a pickle file is. What's Hugging Face? Anybody?
Repository of models.
Thank you. Good. All right. And I want you to stop by the table later. I really do. Right? Guys, we can do this. That's perfect. That's exactly, yes.
Python pickle file to scrape the secure.software website.
Increase transparency.
Oh, nice.
Transparency until nobody can hack.
There you go. There you go. All right, guys, look, this is who we are. This is what we do. Are there any other questions other than using a Python pickle file to scrape your free secure.software site? We'll have an API soon.
You don't need to. You can just ask Grok for one.
Oh, there is that. Yeah, that's a good point. That's a good point. All right, any other questions? Dave, did I forget anything? Matt, did I forget anything? I think we're good. All right, TT, how we doing? And where's my clock? Okay, clock's good. All right. Anybody going once? Going twice? All right. Please thank Patrick and TT and go see Katie. And if you have any questions, please stop by the table. And if I was wrong about anything, come find me and teach me. All right? All right, thanks, y'all.